Hello and welcome to this Java video where we are going to be talking about the Java virtual machine, the Java runtime environment and the just-in-time JIT. Basically, I thought it would be a good idea to go over this, just before we start jumping into the more advanced stuff, maybe like the object-oriented, lambdas, generics, collections, all that good stuff. So I kind of wanted to just give you an overview as to how this stuff kind of works, because it, kind of gives you a more thorough understanding of what Java is and how it exactly works. So let's jump right in. So the Java runtime environment, which is for short as JRE, it's also known, just as Java runtime. So if you hear people talk about the Java runtime environment or just Java runtime, this is pretty much what we're talking about. The Java runtime environment is part of the Java development kit, which is JDK, which you can get online. You most probably have this. It's just a set of programming tools for developing, Java applications that run on any machine, pretty much, which we'll talk about later on as to how Java kind of came up with this concept of, write once, run anywhere. The runtime environment provides the minimum requirements for any Java application, for executing any Java application. It consists of the JVM, which we shall also be talking about, the core classes and supporting files. The JRE, as it says here, composed of the Java API, the JVM. The role of JVM is to read the Java application through the class loader and execute along with the Java API. The Java runtime environment is also composed of many things. It's very complex, so if you want to go jump into this a little more, go into Sun Microsystems and you can read many manuals and documentation as to how this works. But the role of the JVM, which we shall be jumping into, is just to read through the class loader and execute for the Java API. So, JVM, what exactly is a Java virtual machine, or what is a virtual machine? Well, a virtual machine is just a software implementation of a machine, i.e. computer. So if you've ever had a, say like here I'm using a Mac and I don't really want to restart to jump into another operating system, I could just use a virtual machine to fire up a Windows machine, and it executes that machine like a program. And that program seems to think that it's a physical machine. So originally, Java was designed to run based on on a virtual machine, separated from a physical machine for implementing, as I previously said, write once, run anywhere. So although this goal has kind of been forgotten as Java's moved and developed and got more mature, we're at a point now where the JVM runs on all kind of hardware to execute the bytecode without changing the Java execution code, which we'll get into in a bit more detail in our future videos. But yeah, so the features of the JVM, hopefully that makes sense actually what a virtual machine is. Think of Java just firing up these virtual machines so that it can run on any platform, which is very, very helpful. You write it once, it'll run on a Mac, Linux, Windows. Let's jump into the features of the virtual machine. This is where it kind of gets a bit, a bit more complex. And if you want to read into these a bit more, as I said, Sun Microsystems has some brilliant documentation. So we have a stack-based virtual machine, which basically means it's the most popular architecture that Java wants to run these virtual machines on, such as the Intel stack architecture, the ARM architecture, which runs on a registrar, which is a little more complex. So again, if you want to jump more into this, or actually just leave me a question in the comments and I'll do my best to reply. However, the JVM does run based on a stack, and we're going to get into what exactly stack is, the stack and heap, in potentially the next video. So we come to symbolic reference, and what is symbolic reference or referencing? Well, all types, class and interface, except for primitive data types, which we should kind of know what primitive data types are. If not, just do a quick Google. It's not very complex. These primitive data types are referred to through symbolic referencing. So instead of being referenced through explicit memory address-based referencing, we're just using the symbolic reference to link stuff like class and interfaces, to this symbolic referencing. Next, we come to the garbage collection. The garbage collection basically is a class instance which is explicitly created by the user code and automatically destroyed by the garbage collector. So what the garbage collector does, I'm going to go into this a bit more in another video, but it basically looks for objects that are no longer in use, and it will clear up that particular object. If it can no longer reach the object, it will clear it out of the, it'll take it off the heap, and we'll get to a point where we're clearing this up so we don't, have too many objects on the heap, and we can never put more on there. There's certain errors which you look for if you've got like a stack overflow. Can't quite remember the one for the heap, what error you get, but I've got it on my next notes so we can go over that a bit more. But yeah, basically the garbage collector will look for objects and all sorts of. I can't stress how useful the garbage collector is, even though in some languages we don't have the garbage collector, but it is very, very interesting. I recommend looking into this. Basically just clear up certain memory and give you free space. But yeah, so we're going to move on to the guarantee of platform independence by clearing up primitive data types. So traditional languages such as C, C++ have different sizes for stuff like integers according to their particular platform. The JVM clearly defines the primitive data type to maintain its compatibility and guarantees platform independence, which is very neat. Then we come to network byte order. So, byte order, bike. The Java class file uses something called a network byte order to maintain platform independence between the little endian used by Intel's x86 architecture and the big endian, which is done by the RISC series architecture. And we're going to go over these architectures more in the computer science videos. So a fixed byte order must be kept in that sense that we must use a network byte order to keep this in check. So therefore the JVM uses the network byte order, which is used for network transfer. The network byte order is one of the big endians, and it's very useful. It's a feature of the JVM, and these 4 features of JVM very, very useful, very, very complex. So again, if you want to look at them, some microsystems who develop Java, very interesting read. It's good to just understand this stuff, see what you're working with. You want to kind of know what you are working with. However, any vendor can develop and provide a JVM. A good example of this would be Google, who developed the Dalvik VM, which is Google's Android operating system. It's kind of a JVM, though it does not follow the JVM specification. Unlike Java VMs, virtual machines, which are stack machines, the Dalvik virtual machine is a registry-based architecture. So Java bytecode is also converted into a register-based instructions set by the Dalvik VM. And there's been some copyright issues recently based around this. So that's another good read if you want to look into that. The JVM versus the JIT, let's jump down. What is the just-in-time or the JIT? Well, it's an integral component of the Java virtual machine along with the garbage collector. So as the name suggests, just-in-time compilation, capable of compiling Java code directly into the machine language, greatly improves the performance of Java applications. The just-in-time compiler is just, again, a component of the Java virtual machine, increases performance. It's not guaranteed that the code will be compiled on when. Normally, as it just suggests, just in time, just before. So just in time usually compiles hot code in a hotspot JVM once the execution cross certain limits. An example of this would be method converted into machine language if it is not called more than, say, 5 or 10k times. So conclusion, this is just a quick overview of how these things work. I'm going to jump more into the Java, the garbage collector and stack and heap, because we really need to understand how the stack and heap works to, and become a more complete programmer. So, what we're going to do now is basically we're just going to, paraphrase of what we've gone over. So, like conventional compilers build, when you click run or build on, if you build your application in an IDE, the whole program will, get executed to a .exe file before the first time you run it. So for new style programs, assembly is generated with pseudocode only after you execute the program on that particular operating system, Mac, Linux, Windows, e.g. clicking on certain, build icon but with the JIT compiler, when that kicks in and it generates the machine code, that for that particular machine. So if it's that Intel based processor or whatever that processor is, the JIT and the JVM, which is, well, the JIT is an integral component of the JIT, it will, you know, generate that particular code for that particular machine based on that particular processor. So again, knowing these components and these features of Java helps you have a better understanding, more thorough understanding of how Java works. If you want to have a deeper understanding of this, you don't really need to if you're just working with high-level code, but it is really useful to understand, and it helps your job prospects and everything else for that matter. But if you do want a more advanced overview, be sure to check out Sun Microsystems. Their website's very useful for anything when it comes to Java. Also, as we come to the end of this video, the next video should be based around the garbage collector, or the stack and the heap. The stack and heap is, you know, it's imperative that we go over that. So yeah, remember to subscribe for more videos. It really helps out, and I can kind of get feedback as to how these videos are. And be sure to leave comments if you have any questions. I really want some feedback on these videos as to what you'd like to see. I want to start pumping out more videos now. I'm not away, so I can start helping you guys and girls a lot more. Feel free to ask me questions in the YouTube comment box below, or you can follow me on Twitter @CarlHadwin. Thanks for taking the time to watch this video, and I shall see you in the next one.